Welcome everybody. Today we are going to be working with complex numbers. We will be multiplying them, dividing them, rationalizing denominators, and simplifying the absolute value of a complex number. So the first thing is multiplying complex numbers. Now, if this were any other variable, we would just multiply and get 30i. And that's what you're going to do here. In this next example, we are going to multiply negative 2 times 10 is negative 20. I times I is I squared. Well, that's wonderful, except one of the things we noticed in our previous work with square root of a negative 1 is that I squared can be replaced with negative 1. So this is negative 20 times negative 1, and that's just 20. And there is your answer in that example. Now let's take a look at some distribution, more than just simple multiplication. If I were distributing here, this would give me 6i minus 14i squared. And we already know from the previous example that I squared is negative 1, so that makes this whole expression opposite sign without the I. So 6i plus 14. But in an earlier lesson, we discovered that complex numbers are expected to be written with the complex part of the number listed second and the constant part of the number listed first, or the real part of the number listed first. So this should be 14 plus 6i, not 6i plus 14. This is the proper form for a complex number to be written in. Let's take a look at our next example. So I'm going to distribute 4 minus 12i plus 8i minus 24i squared. Well, we know from our talk that this is going to change to plus 24 without the I. And now I'm going to combine like terms here. 4 and 24 is 28. Negative 12i and positive 8i is negative 4i. And that's the result you have when you distribute here. Here's our next example. First thing you should note is that when you are squaring a binomial, always write it twice. And then distribute. Don't try to apply the exponent in, because that's not how it works. Now I'd like you guys to give that one a try to see if you can do it all the way through and simplify. Unpause the video when you're done. All right, so distribute. That would be a 9 minus 30i minus 30i plus 100i squared. Well, 100i squared becomes negative 100. And when I combine like terms, I get, let's see, negative 91 minus 60i. I combine my negative 30i and negative 30i, negative 60i, 9 and negative 100 is negative 91. All right, now we can talk about divide, rationalize, and rationalize with complex numbers. All right, so when the denominator is a binomial, that's the next example. This is our first example. I have an I in my denominator, and there's no addition or subtraction there. So to get rid of the I in the denominator, just like we rationalized with square roots, we're going to rationalize here by multiplying by I. This gives me 4I over 7I squared. Well, that's great, but the i's aren't gone in the denominator yet. Well, remember, I squared is -1 times 7 is going to be 4I over -7. And now I have a rationalized denominator. No square root, no I. Let's look at this next one. As I was just trying to say, when the denominator is a binomial with I, you must multiply top and bottom by the conjugate. Now, I don't expect you to remember the word conjugate, though it'd be good to keep that in mind. A conjugate is basically taking the denominator in the bottom and changing the sign between it, and that's what you multiply top and bottom by. So you take this 4 and the I and you change the sign to the opposite sign from what it was. Now if it was minus, you make it plus. If it's plus, you make it minus. And we multiply the top by the same thing. Remember, when you multiply a fraction by something, if you want it to stay the same, you have to multiply top and bottom by the same value. Numerator, denominator by the same value. So I'm going to multiply this, and I'm probably going to need a little more room. So I'm just going to move this down a bit so it's out of the way. All right. I am not going to distribute the 8 yet, and I'll show you why. We will probably distribute it in a minute, but I have to do some distribution and simplification of the top first, or the bottom first. So let's do that in a different color. 16 plus 4I minus 4I minus I squared. Now, the big key here as to why we switched the sign was so that our middle term would cancel out. We have a positive 4I and a negative 4I, and that's how they're going to cancel out. This becomes a positive 1, so my result here on the denominator, in the denominator, is 17. Now I know that's not going to reduce with the 8. If it had been 16, I could reduce with the 8 instead of distributing first, and that makes our job a lot easier. But since it just comes out to 17 and that's not going to reduce with the 8, I'm going to go ahead and distribute 32 plus 8I. There is my final answer in this situation. Let's take a look at this next example. There we go. So here, I need to multiply by the conjugate. And in this case, 5 minus 9I. Opposite sign, but the same first and last terms, except for the sign. So I'm going to go ahead and distribute. Now I need to distribute top and bottom. So on top, negative 5 plus 9I minus 30I plus 54I squared. That's the top. The bottom, 5 times 5, 25 minus 45I plus 45I minus 81I squared. Just like before, this is going to become negative 54 without the I, and this is going to be positive 81 without the I. Now I'm going to go ahead and combine some like terms here. Let's see. Negative 5 and negative 54. Negative 59 minus 21I over, let's see, these cancel, 25 and 81. Let's see, 106. Well, that's not going to reduce with anything on the top. I can't factor out something to reduce with that. So that's going to be my final answer here. Now, talking about reducing, sometimes you have a problem. Let me draw a line between these so you know these are not connected. They're not part of the same problem. Sometimes you have a situation like this, and you can see that something can come out of here. So let's go ahead and factor out, how about a 20? Because 20 is what they have in common. So if I factor out a 20, I get -3 minus I over 106. I used the same thing here, but I made these so that they could reduce with the 106. Now I first factor it out because I don't want to reduce here and forget to reduce with this one at the same time. So the proper way to do it is to factor out what they have in common, reduce, and then if you have to, redistribute. I know 2 will go into 20 and 2 will go into 106. I don't believe any more will go into either one at the same time. So I'm going to reduce by 2. This would be 53. This will be 10. So that simplifies when I distribute back in to -30 minus 10I over 53. That's how you would reduce there. All right, that's division. Last topic here is absolute value of complex numbers. The absolute value of a plus bi, remember that's the general form for a complex number, is equal to the square root of a squared plus b squared. What do you notice is missing in this formula? The I. I is not involved in the absolute value of the complex number. It's not there at all in this section. So when we do this, you ignore the I. So if I do this one, the square root of 2 squared plus 12 squared, I is not involved. Well, that would be 4 plus 144, or 148. Now I can see that 4 goes into 148. Remember, you should have it in simplest form, simplest radical form. 4 times, let's see, 4 goes into 14, 3 with 2 left over, 37. 2 and 2, 37. I'm going to pull out the 2, square root 37. It does take a little remembering, but you know, back to when we simplified square roots, but it's worth you doing. All right, over here, square root 5 squared plus -10 squared. That's going to simplify to 25 plus 100, or 125. And we know that breaks into 25 times 5, 5 times 5 times 5. I have a pair of 5s. I pull one out, and 1 5 stays in, and I have my final answer of 5 square root of 5. Now you may think about this and say, wait a minute. When I had the plus sign, both my numbers were positive after squaring. When I had a minus sign, both the numbers are positive after squaring. And it's true, because anytime you square a negative number, you get a positive number. If you square a positive number, you get a positive number. So does this sign or a sign with this number have any impact on the final result? The answer is no, it doesn't. Because the final result will still be the same whether this is positive or negative, this is positive or negative, or either one is switched. It doesn't matter at all. It'll come out to the same depending upon the A and the B It's almost the absolute value of A and B that we're working with. All right, you guys give these a try, see how you do on them, and unpause the video when you're done. I'll go through it. All right, so square root, -7 squared plus 4 squared, 49 plus 16. Let's see, 6 and 9 is 5, carry the 1, 4, 5, 65, square root of 65. Over here, don't jump the gun, Eric. Here we go. -3 squared plus -11 squared, 9 plus 121, 130, and I do not believe that's going to break down any further. 130, 13 times 10, 13 times 5 times 2, no pairs, you're done. All right, that is our lesson for today. I don't believe I've got, oh, no, I do have one little thing left. If you had this can be written 2 ways. I just wanted to show you this because I realized before that I didn't mention it and I wanted to today. So there's 2 things you can do. One way is to rewrite this so that it's separate fractions. 30 over 22 plus 20i over 22. These reduce to 15 over 11, and this can be written as 10 over 11 with the I to the side, because if I multiply a single term times a fraction, you just put that single term over 1 and multiply, so that'd be the same as 10i over 11. And this is the way the book likes to write the answer. 15 elevenths plus 10 elevenths I. That way it's still in A plus B times I form. However, it's just as good to simplify this fraction by pulling out a 2 on top and having 15 plus 10i over 22, reducing, I don't know why I didn't switch colors, and 15 plus 10i over 11 as your answer. That's it for today. I hope you have a great day.